Hey everyone, today we are going to get into the nuts and bolts of how you build your AI stack. And trust me, for most teams, things are about to change in a big way. We're going to explore how you can build systems that are not just powerful, but also smart, sustainable, and, actually affordable.
So let's just jump right in. I want to talk about the single biggest mistake that I see almost every AI team making right now. It's a quiet one, and it kind of seems logical at first, but it is just silently draining budgets and killing projects before they ever have a shot at scaling. And this quote, it just absolutely nails it. I mean, imagine you hired a Nobel Prize-winning physicist, and their only job was to greet people at your office. It's an insane waste of talent and money, right? Well, guess what? That is exactly what is happening in the world of AI development every single day.
The problem has a name: model-task mismatch. It's this habit of just throwing your most powerful, most expensive model at every single task. Doesn't matter if it's rewriting an email or doing complex data analysis. Look, this isn't quality control, it's a massive financial leak. You're paying for incredible reasoning power that you just don't need for most requests. So, okay, if that's the problem, then what's the solution? Well, it's going to require a pretty fundamental shift in how we think about building with AI. It's not about finding a better model. It's about designing a better system. This is what we call the orchestration paradigm shift.
And here it is, the core idea for today. Looking ahead, the companies that win aren't going to be the ones with some exclusive access to the single best model. No way. The real victory, the sustainable advantage, is going to lie in the intelligence of the system that manages all the models. It's all about the orchestration. And the hero of this new approach, it's the intelligent router. I want you to think of it like an AI traffic cop. It's a small, incredibly fast, and very, very cheap model. Its only job is to look at a request, figure out how complex it is, and then immediately send it to the right specialist for the job. Okay, so how do we actually put this router to work? We build a system around it. And the most effective way to do that is with a clear, actionable framework. So let's get practical and break down the 4-tier model strategy. All right, this visual here shows you the whole system. Now, don't worry about reading everything at once. Just focus on the center. See that? The intelligent router is acting like a funnel. It takes in every single request, figures out how hard it is, and then smartly directs it to the correct tier on the right. This one step is what stops the budget from bleeding out. So here's how it all breaks down. Tier 1 is our router, right? It's that lightweight model, and it's handling a massive 80% of all the traffic. The simple stuff. Now, if a task is a bit more complex, say multi-step logic, it gets promoted to a Tier 2 workhorse. Only the most critical, high-stakes tasks ever make it to the expensive Tier 3 and 4 models. We're saving our PhDs for PhD-level work. And this right here, this shows you why it all matters. The economics are just staggering. Just look at the price difference per million tokens. These are projections for March 2026. A Tier 1 router, we're talking cents, maybe 25 cents. A frontier model could be up to $30. That's more than a 400x difference. Using a frontier model for a Tier 1 task is, well, it's just fiscal insanity. But the sticker price per token is only part of the story. If we really want to architect an efficient system, we have to understand the hidden costs, the ones that can blow up your budget without you even realizing it. There are really 3 main culprits here. First, context bloat. This one is huge. Sending massive chat histories or entire documents with every single call is a guaranteed way to burn cash. Second, hidden reasoning costs. You're actually getting billed for the model's internal thinking tokens, even if they don't show up in the final answer. And third, the retry tax. This one is so important. A cheap model that fails 3 times can easily end up costing you more than one reliable, premium model that just gets it right on the first try. So, now that we understand the obvious costs and the hidden ones, we can finally put it all together and architect a system that's built for efficiency right from the ground up. And honestly, it really boils down to this simple comparison. The naive approach just sends everything to the most powerful model it can find. Sure, it's easy, but it's incredibly wasteful. The optimized approach, the orchestrated one, intelligently assigns each task to the right-sized model for the job. And the results, they are not subtle. I mean, this chart says it all. A single model architecture represents this massive, towering cost. But the multi-model orchestrated approach, it is a tiny, tiny fraction of the expense. And you don't even sacrifice quality on the tasks that actually matter.
To put a really fine point on it, we are talking about a potential 92% reduction in your operational spending. That's not just a small optimization, that is a complete transformation of your unit economics. It's the difference between a project that can actually scale and one that just burns out. So how can you start thinking this way, like right now? Use this simple checklist for every single model call. Just ask yourself, 1, is this task simple enough for a cheap model? 2, what's the cost of failure if it gets it wrong? 3, does this step really need the entire context? And 4, can I shrink the tokens before I hit send? Just this checklist alone will start saving you money.
So the big takeaway is this. The winning strategy isn't just about using a bunch of different models. It's about designing a system where cost is a primary factor at every single step. That is cost-aware orchestration. And that really leaves us with a final thought to completely reframe your approach. Stop asking which model is the best, and start asking, how efficiently can I allocate the right amount of intelligence to this one specific task? Because that is the question that separates the prototypes from the scalable, production-ready AI businesses.